Okay, so we had one final thing to think about, and that's estimating p-values using the critical value tables in table C at the bottom. So I've copied part of table C over here. Here's the critical value for Z. Here are the various values you might expect to see for Z. And here's the one-sided p-value corresponding to that Z value. So that's the upper tail probability. I should say that. Upper tail probability. And this here, a two-sided one, is the two tails. Sum of two tail probabilities. Okay. So already computed for you. The problem is that your computed Z value won't be one of those numbers, and so we have to estimate the actual p-value when the Z falls between the two critical values. Then the p-value falls between the two p-values listed, either it's a one-sided or two-sided test. Let's see how this works. So here's a one-sided test, the same one we did. We got Z of 1.875. We're interested in this upper tail probability. So that row, the top row there, under Z star, tells you upper tail probabilities. We're trying to find a Z of 1.875. 1.875 is between 1.96 and 1.645. So since that, put it here. So 1.645 and then 1.96. They straddle the 1.875, and so the tail probability of this is a little bit bigger than that for 1.96, which is 0.025, but smaller than the tail probability for 1.645, which is 0.05. So it's between 0.05 and 0.025, and so the critical thing is it's less than 0.05, like that. So looking at it, see the 1.875 is larger than 1.645. That makes its tail probability less than the tail probability for 1.645, which was 0.05. Okay. So that would make us reject the null hypothesis. Okay. And then for the two-sided test, we got a Z of 2.7. We're looking for 2.7 up here. The 2.7 falls between here and here. The p-value is a two-sided, it's a two-sided test, so the p-value is sum of the two tails. So we go with the two tails, we look for 2.7. Here the upper tail probability is already doubled. So it's just this thing doubled, that thing doubled. So 0.01 and 0.005. We computed it to be 0.007 approximately, that's between those two values. So without the whole Z tables, with just the tail probability tables, the critical values for Z tables, we can estimate the p-value, and usually that's good enough for us because we just want to know, is it less than some number? So less than 0.01, like that. So that would say it'd be significant at the 0.01 level, and also the 0.05 level, because if it's less than 0.01, it's less than 0.05. Here we just said it's less than 0.05, but it's going to be bigger than 0.02. So write it here, greater than 0.02. 0.025. So greater than 0.01. So that result would not be considered significant at the 0.01 level. This one over here significant at both levels just from that table. So for some other examples, here's a less than alternative with a Z value of minus 1.43. So since it's a less than alternative, we want a left tail. But the normal distribution is symmetric, so to find that left tail, we just make this positive and find the right tail. So we're looking at 1.43. Here's where 1.43 stands between 1.282 and 1.645. It's a one-sided test. It's a one tail. The one tail for that value would be the same thing as the one tail for 1.43 above. And so that would be, here's the one-sided test, between 0.1 and 0.05, the p-value is between 0.1 and 0.05. But that makes it greater than 0.05. So we would not, if we got that as our critical value, our z-value, it's not enough of a negative number for the tail probability to be less than 0.05, and so it would fail to reject the null hypothesis. What about this guy here? It's a two-sided alternative. The z is minus 1.72. Hang on, so I'll draw the picture of that. Here we go. Not the best. Minus 1.72. We need the two tails. Like that. So since it's two-tail tests and not equal to alternative, we can just as well look up 1.72 in the tables and double that tail probability, which means I can go to the critical value table, look at the two-sided alternative, find 1.72. 1.72 falls in this range, between 1.645 and 1.96, so the p-value is between, I'm looking at the two-tailed, two-sided test with a z of 1.72, which is the same as z is minus 1.72 for testing purposes. Here are the two-sided probabilities, so the p-value is between those two values, 0.1 and 0.05, and so greater than. All right. Well, you're in a position now to get working on the homework. It goes with chapter 17. I imagine making it through all these videos, you should just probably watch 5 or 6 at a time, let it settle, and come back and watch some more, or maybe just look at some of the homework problems, see what happens. This is a lot to digest. It'll take us several passes through it. I've got the notes that you can look at and all these videos. That should help you. And then we'll have our regular class time for discussion purposes. And this is probably one of the harder parts of the class. If we can get through this in one piece, then things follow the same kind of format in the future and everything will be fine. Hope you're having a good, what do they call it? A good locked in your house existence. You've got plenty of food and lots of Netflix videos for when you don't want to be studying or whatever else it is you want to do in your copious time locked in your room. You're still allowed to go for walks and things like that. And let's just hope this all, as they say, blows on by us and we can get back to our normal life in the near future. But I'm thinking somewhere maybe in the middle of summer things might get back to normal. So just try to make sure you're ready for that and just keep smiling. And I'll see you guys online when you show up for class.